been calls for attention to destruction of the ozone layer, global warming, and other environmental problems for a long time. For example, isn't it true that we have not been very aware of the effects of the destruction of the ozone layer? Even so, we can feel the effects of environmental destruction close at hand in our everyday lives in an increasing number of situations. Measures against global warming, which began with concern over the destruction of the ozone layer, and trends toward global environmental measures, such as the Kyoto Protocol, are now exerting a major influence on the actions of corporations. In the future, there will be demands for stricter management of volatile organic compounds, or VOCs, which we've been hearing so much about lately. The times are such that unless companies can adapt to a society that demands management of chemical substances, their very existence, or at least their value, will be compromised. While environmental regulations are being strengthened, the economic environment that companies find themselves in means that at present, measures against atmospheric pollution have not advanced very far. In our production-oriented society, isn't it true that the best option is for us to protect the environment and continue producing goods at the same time? Until now, Morikawa has been concentrating on recovering and recycling the organic solvents from its plants and developing equipment that will let it continue its production activities and protect the environment at the same time. The result is our Soul Trap S series, with its own unique liquefaction method. This flowchart shows how the liquefaction mechanisms work. First, the gas taken in is compressed to about 0.5 megapascal in a compressor. Compression raises the temperature of the gas, and it then goes into a water-cooled condenser, where it is cooled to 20 degrees Celsius, undergoing preparatory cooling before the highly concentrated gas is further condensed and supercooled. Next, the gas is cooled to between minus 30 and minus 40 degrees Celsius in the supercooling compressor, which liquefies up to 95% of the input concentration. Here, the solvent gas that could not be liquefied is captured through an activated carbon adsorption process, so that 99% or more of it can be eliminated. The gas that is adsorbed by activated carbon is heated in a heat exchanger using the heat generated by the compressor and efficiently desorbed through decompression caused by intake into the compressor. This method allows us to capture high-quality solvents since there is almost no moisture in the solvent gas during adsorption, and degradation is minimized with a structure that allows low-temperature adsorption without the use of steam. Being able to collect solvent gas near the source of its generation saves space and lowers facility costs, allowing economical recovery. In addition, the Soul Trap S series can meet a wide variety of other needs, including recovery from tank vents in chemical plants or recovery of extracted solvent. Unless management of chemical plants is further enhanced in the future and companies make efforts to reduce their emissions, it will affect not only their economic activities, but also the environments in which people live their everyday lives. Morikawa aims to make the sustainable society a reality, and with recovery and reuse as its major areas of concern, it is continuing to meet the challenge of developing technology that allows both environmental protection and production of products. Many processes lead to VOC emissions, and each one requires a different set of measures for handling these emissions. We intend to build upon our existing technology to create new technologies that will make us the leader in producing recovery equipment. It's up to us to protect the global environment in which we all live.